All right, this video is going to be a little bit more covering with central angles, reiterating what they are, how we find them, and then we're going to move to arc length. This will be the third page of our notes at Katy High School in spring of 2024. As just a reminder, I mean, we just did this, but on the previous page, but in a circle, the circumference, the outer circle, has a degree measure of 360. What I need you guys to understand is when we move to arc length, you're going to see a difference. Degree measure is degrees. So if I ask for the measure of an arc, okay, which on our previous page we saw little m's next to the arcs, meaning I want degrees. The circle, the central angles, the outer circle, the circumference degree measure is 360 because its central angles all add up to 360 degrees, and the central angles and the arcs are exactly the same measurement. So we're going to go ahead and do two more problems here. We're going to take all of this, all these central angles, and we're going to add them to equal 360 and solve for x. So we have the x plus 130 plus the 90. This is, I'm just going to go ahead and do this on the video since it's pretty basic. We're going to combine the like terms, get x plus 220 equals 360. And then we subtract that 220, and x is going to equal 140. Now I want you to pause the video and do example number 2 on your own. We're doing the exact same thing we just did example 1. We just have one additional central angle to add together. So go ahead and pause the video and solve this on your own, please. So this is our very long equation. So we'll go ahead and make sure that we have this to begin with. It may be in a different order, and that's fine, and then we'll combine our like terms and solve. And let's make sure that we got 30. Now, arc length. Arc length is different. You're not going to have a standard number that it's always going to be, like the 360. Your arc length is going to come from your circumference, and your circumference is measured in inches, feet, yards, centimeters. This is going to be the physical length of that circumference or the arc, and it will be different. So now we're looking at length. Measure, arc measure is degrees. Arc length is going to be inches, feet, etc. So we remember our circumference formula. There are two different ways. You can do pi times diameter or 2 times pi times radius. We're going to use this one, 2 times pi times radius, because your arc length formula. You can use proportions to get through everything. We're just going to go ahead and spill out exactly what this formula is. Your arc length, we need to remember what theta is. Theta, T-H-E-T-A, is this funky looking thing. Trigonometry, we learned that this is going to be the angle measurement. And we're going to multiply it times pi times radius. And this will all be over 180. Theta is the central angle. And r, we should know, is radius. So you're going to have two things we need to plug in on this. Let's take a look at the first problem. Example number 5. We're going to find the circumference, and we're going to find the length of arc GH. Again, we had this little m on the previous page. Measure of arc is going to be degrees. Measure is in degrees. If we don't have the m, this is the length. So we see whatever our radius is labeled with, in this case inches, that's what our final answer is going to be labeled with. So to find our circumference, first let's look at when we get to our arc length, we're going to need theta and the radius. So we look here, we see that the radius is 4 inches, and theta is going to be 75 degrees. For circumference, we'll go ahead and plug in for the radius of 4. Now we find, now that we are, not now that, but we are in high school, we do not use 3, we do not use 3.14 for pi. You need to use the pi symbol in the calculator. 3.14 is drastically rounded, therefore your answer could come up pretty off. Okay, so we plug 2 pi symbol parentheses 4 into the calculator. We'll round to the nearest tenth. We're going to wind up with approximately 25.1 inches. And circumference is measured with whatever unit of measure the radius is in. Now your arc length. Let's take a look at that. We're going to go ahead and take this arc length, this new formula. In the numerator, we want to plug in theta, which was 75, followed by the pi symbol, followed by the radius of 4. This will all be over 180. My suggestion, plug it all into the calculator at one time. Do the fraction function. Type in 75 in parentheses, pi, parentheses 4. In the denominator, plug in that 180. If we round this to the nearest tenth, we're going to wind up with approximately 5.2 inches, not degrees. Length is not degrees anymore. All right, so let's go ahead and take a look at example 6. We're going to find the circumference and the length of JL. What I did forget to do, I'd like to do here is highlight what it is we're finding. So again, these are both going to be our minor arcs, so the central angle is going to be under 180 degrees. We take the shortest path possible. So here we're given the diameter is 10. But if you look, yes, your circumference, you can use the pi times diameter, but because we need the radius, you cannot use diameter in the arc length. So I'm going to go ahead and put in that my radius is 5, and I'm going to put an X through the diameter so I don't accidentally use it. And now we'll find our theta. Arc JL, the central angle theta was 120. So let's go ahead and start off with circumference 2 pi r. Encourage you, pause the video, do this on your own. We substitute in, we get 2 pi times the radius, which is 5. Plug everything in with that symbol, we're going to get approximately 31.4. And this is labeled in centimeters. Arc length. All right, back up to our formula here. Theta, central angle 120, times pi, times the radius of 5, all over 180. We plug everything into the calculator, let the calculator do everything for us. We're going to wind up with approximately 10.5, and this is measured in, again, in centimeters. And that concludes our arc length and central angles and arc measure. Just big thing. Arc measure, degrees. Arc length, whatever unit of measurement the radius or diameter is given